Hi, um, I'm Ulrich von Sado, and I'm going to be talking about media system deployment using Python. Um, the idea is, um, well, what is media system deployment? Um, First thing, media systems are things like blinking lights, things like the airlock we've put up in the sea base, things like, well, at the bottom you can see a telescope thing which we've worked on at my employer's Artcom. That does usually things that don't look like computers. Um, Sometimes things like home cinema, that's a media system. Um, Now the problem with this is they are very, very diverse. And I've tried to characterize them. You've usually got a lot of strange input and output devices, from remote controls to push buttons that are not normal keyboards to Bluetooth cell phones and things like that. In most cases, you won't have a keyboard, and in most cases, you will have a screen. Okay, then, so what is deployment? Deployment means I'll be talking about all the phases of what it means to actually make a media system. It starts, well, it's actually an adaptation of a standard IT deployment technique. So you start out by building yourself a concept. Usually the difference between those two is that you're going to be working with very different people. You're going to be working with artistic people, meaning yeah, people who usually don't use computers all that much and have a very different view of the world than a usual IT person. Those people are usually going to be very active during the concept phase. They will be talking to, if there's a client, they will be talking to the client, find out what the client wants, and figure out how things would look best would act best. Next phase, design phase. That's a bit different than the usual software design phase because you will have a lot of interface design. What buttons do we put where? Things like that. You will have graphics design, screen layout stuff, things like making small movies that are put into the presentation, things like that. Sound design, actual recording of sound, maybe hiring an orchestra if you get to that. Industrial design, meaning what stuff do you put into, what's the setting that the whole thing is going to be in. It usually doesn't look like a computer at the end. And you've got the usual technological software design stuff. You've got an implementation phase. That's not much different from the rest of software. And you've got a rollout phase where the computer actually gets put into the place where it's supposed to be. Well, this thing sort of says do every step, one step after the other. The alternative is doing everything at once. That usually is a lot more fun because it gives you more freedom. Because if you're the implementer of something, the concept is done. Somebody's done all of the optical design. There's no ideas you can put into it anymore. Also, the designer isn't as flexible because you won't know enough to really tell them what you can do at that point. There's cons. You need to speak the same language as the people you're working with. So if you're the implementer and you're talking to an artist who's doing the concept, usually that doesn't work out. You don't talk the same language. That's a learning process because yeah, you've learned how to build software. You're a very technical-oriented person, and the artist is somebody who's got lots of ideas and may not now know how easy it is to implement them or how hard. Doing everything at once is also hard to plan, which means if you have a fixed date when you want to be finished or a fixed budget, that leads to problems. Okay, I'm going to go to an example of a concept we did. That's a, well, basically a body and hand scanner we put up at the sea base. I hope I have it here. Yes, I do. How do I get this smaller? Okay, this is the concept we came up with. This was a lot of talks. It was mostly a, well, it started out as a phase thing. We started out with a concept, we did some design, I implemented some stuff, and then things went wild and we changed concepts and implemented some more and didn't keep to the phases anymore. It worked out pretty well, I think. This is basically the concept document we came up with. So you have, at the beginning, you have this scanner that's telling you to put your hand on it, and then there's a scan that happens, and if you remove your hand, of course, it tells you something, and it gives an alarm maybe. If it recognizes you after the hand scan, it might just immediately, things like that. It'll do a body scan if it doesn't immediately recognize you, things like that. You can see the, I'll have to get this a bit bigger. You can see how far this goes. There's no actual media here. There's terms about the lighting. Sorry, it's in German for those who only speak English, but I assume that's a minority. There's going to be talk about what media to use, but the actual media aren't done yet. So ambient audio, there's lighting at the floor, there's an animation on the top screen, things like that. Okay, and it goes on and on and on and on, and it has some transitions and some movies and whatever. And when we get to the technology part, I'll show you what we came up with at the end. Okay, now the part of the title I haven't talked about is why Python. To implement the media systems, I decided to use Python because, well, okay, A, it's a scripting language, meaning you don't have any compile times to waste. It has a very, very clear syntax, meaning it's a lot easier to read than a lot of other languages. There's a very, I think there's a statistic that there's, code is usually read 10 times more often than it's written. Which sort of says you don't want a lot of ways to express yourself. You want to have one way to write code, and it's got to be easily readable. Another reason for Python was that there's lots of libraries you could use. I'll be going through a lot of libraries in the rest of the talk, so that's I'll be coming to that. And it's easy to write your own libraries. I'll also be talking about how to do that. It's a very structured language, object-oriented stuff. You can do some functional stuff, and it's fast enough for most of what you want to do in media systems. Okay, I've found two very good ways to learn Python, online books or tutorials. One is the official tutorial written by the guy who also is like the father of Python. It's a good intermediate level tutorial, and a very fast, very good tutorial for people who know what they're doing anyway, but who don't know Python, is Dive into Python. Okay, getting to the libraries. to put up a system like that, what are you going to need? You need some visuals, something to put on the screen, something that allows you to mix stuff on the display. The library I've used for that, actually the library I wrote for that is libavg. You might need image processing stuff. There's a Python image library called PIL, and there's a wrapper for ImageLib2, which, well, KAA ImageLib2. If you need sound, there's two wrappers for a 3D audio library. The audio library is OpenAL. The wrappers are ALPy and PyOpenAL. For videos, there's wrappers for the Zine library available, and you can use those. I won't be talking about all of those libraries. I'll be talking about those that I know well. Okay. For those of you who read the introduction to the talk, and also maybe for those who were there last year, you will have heard of libavg, and you might have sort of, yeah, you might have gotten the impression I'm doing this talk because I want to promote libavg because I think it's a cool library, and I do think it's a cool library, and I do want to promote it, so you're right. It's a framework for media presentations, for media systems, meaning you have a very clear wrapper around what you can do. It allows you output of videos, of text, formatted text, meaning all sorts of fonts, boldface stuff, UTF-8 support, which is support for right-to-left languages, support for Chinese, Japanese, whatever. Images, obviously. There's support for FireWire cameras if you need that. There's a pretty cool layout model, which means the way you put things on screen is a box model. You have relative coordinate systems in which to put stuff. The stuff gets put on layers. You have opacity support, you have alpha blending support, and all of that is totally integrated, meaning if you want videos behind other things, videos with alpha, things like that, everything works. The presentations and the systems can react to mouse, keyboard, stuff like that. And obviously you have the whole Python language available to you as scripting. Timeouts, you have some support for generic animations. And I'll go to some examples. First thing is what you just saw the concept of. Whoops, where is it? Which is the scanner that is at the C base. This is, usually it's on two screens. In this case, I don't have two screens. So I have to make do with what's here. This bottom part here is the bottom screen where you can put your hand. The top screen is well, just a screen that displays whatever happens. And if you put your hand here, because the top screen, the bottom screen is a touch screen, you have this happen. And obviously you won't be hearing anything here, but this thing is making noise. Scanning your hand, scanning your body, figuring out who you are, and finally allowing you to enter the place. And if you don't remove your hand, it'll tell you to go on. Okay. Second thing, oops, where is it? Is just a monitor that displays some stuff also at the C base. It'll take a while to load. It's just there to display current events and show some advertisements, some rather unreal advertisements. Bad network connection, I think, I hope. Otherwise we'd have this sooner. Or I don't have a network connection at all at the moment, which is entirely possible. Nope, there's a network connection. No, there wasn't a network connection because it's timed out. Otherwise, at the top region, we'd be seeing some of the current events. Okay. One of the interesting things, technologically wise, is that there's a video here that's being shown, and it's behind everything else, which is something that you won't be getting in a lot of places. That's usually doesn't work. Usually people don't get this to work. Okay. And this is just a technology demonstration I did. I called it Video Chooser because what it basically does is allows you to choose amongst lots of videos in one directory. And the wild thing is that you can basically choose by moving your mouse. These are the entire first episode of Enterprise we're showing at once. And if you want to see more at once, you can do it this way. Okay, so what does this look like? Okay, and I'll just open the code that does this because the real interesting thing, I think, is that it's just a few lines of code. This is, wait. What a libavg system is made of is basically a Python script, which is here, and an AVG file, which is a glorified XML file that says that has the screen out layout in it. Now this is an incredibly easy screen layout, obviously, because there's just tons of videos in it. And all the magic happens in Python. That's not always this way. We'll get to a different layout later on. So what does this thing do? Now we'll start at the very beginning. Import AVG, that's tells it to use the library itself. And then the actual code happens here. You get yourself a player, you get yourself a logger. That's the stuff that happens here. Tell them what to log. You load the XML file, the AVG file. This is where some magic happens. And then you can start to basically change the XML nodes here. Give them positions, give them opacities, tell them where to find the files they'll be referencing. In this case, it just sets the opacity. No, nothing magic happens here, sorry. It just sets the opacity to 0, so everything disappears at the beginning. And then, yeah, position videos is where the magic happens, I think. Gets all the videos. Gives them an X position, gives them a Y position, a width and a height. And yeah, the offset gets put in. At the beginning it's 0, and later on it's going to be the mouse position. So at the beginning, this is just going to be setting X and Y positions, width, height for all of the videos. And starting those that are visible. And then you start a set interval. That means every frame, in this case every 10 milliseconds, that's a lot more than every frame. It can only do one frame, at most one call each frame. So what will it do each frame? Get the mouse position, find out where it's happened, calculate how wide the video is supposed to be and how high the video is supposed to be depending on where the mouse is. Calculate the X position of the videos depending on the X mouse position. So the higher I move the mouse, the bigger the videos are going to be, and as I move it from right to left, the videos are going to move from right to left too. And then we call the position videos thing again, and everything happens. So the magic behind that is obviously that there's a library that translates this .x, .y, width, height stuff into things that happen on the screen. Yeah, well, that's all that happens in this thing. And that's 80 lines of code, and you get this. Okay. I'll have a short walk through this monitor so you can see the layout stuff. This is a more complicated layout because, I'll start it for a second again. You can see that there's lots of elements in there. It takes forever to start. I'm not going to start it again. I can't stop it. Okay. You can see that there's lots of, yeah, I stopped it. Lots of different screen elements. So there's a video in the background. You can see it here. There's a box making up the top screen, which is again divided into, where is it? 3 lines. And all of these have relative coordinate systems, X and Y, and a maximum width and height, which are used to crop everything that's in it. And there's a bottom screen, and you'll have all the fake ads we have here for Star Soda, and there's a few that aren't shown, and for the Sea Wars trailer we had earlier on. Now if I start moving things around, things are going to move around. No, I won't do that now. Okay, we'll go back to the rest of the presentation. Do I have it? Yeah, okay. Things that can be used to work together with this there's a Python imaging library that can be used to do lots of image processing stuff. Very well documented, very full-featured, lots of stuff you can do with that. It's mostly used, I think, at the moment to do web applications. So people who just want to blend some images for a web page, things like that, are using it. But it should be very, very easy to integrate that into media systems. There's an open source version and a commercial version. The open source version has a license that's very short and looks very okay to me, but yeah, I'm not a lawyer, and if there's any question about usage, it's not LGPL, it's not GPL, it's not BSD, it's something strange. Okay, what does this thing do? You can load images, you can save images, you can crop, scale, rotate, blend, whatever. You can apply filters to images, things that you couldn't do with libavg by themselves, like add sharpness, change the contrast, do blurs, sharpen, everything like that. You can draw on images, everything that's supposed to be drawn on images, lines, arcs, ellipses, polygons, just the general basic image processing stuff that people will use. Commercial version supposedly has some, let's say, image processing in the realm of image recognition and stuff like that, as far as I've seen it. But that, okay, if you need that, you gotta pay. The problem with it is that I haven't done it yet. I haven't really gotten the images from PIL to libavg. I was going to do it, and I was actually going to do it yesterday, but it didn't happen. It should be, in theory, like every programmer says, it should be a few hours of work, and I hope it is. The idea is to take images, change them, blend them, draw on them, whatever, and use them as integral part of media systems again, of the libavg presentations. Okay, moving on farther. What options do we have for sound? This is probably the most stupid option. You just use Python to call an external program, and that'll play a sound file. It works. It works stably, and there's it just isn't good because the performance isn't good. You're just starting a new process every time. You've got process cleanup issues as long as you don't. Well, you need to fork because you can't start a process in line, otherwise everything else will stop. So you also have threading problems. You need to clean up the zombie process afterwards. That's just stuff you don't want to have, you don't want to deal with usually. There's no way to loop it. There's no way to set the volume. It's just not the way to do it. Second option, ALPy. Is that supposed to mean something to me? No. ALPy is a Python wrapper around OpenAL. OpenAL in turn is a 3D sound library. Has a similar interface to OpenGL for those people who know OpenGL. And it's actually incredibly powerful. It just allows you to put sounds in 3D space, define speaker configuration from stereo to however many speakers you have. I think 7.1 is the realistic maximum. Creative Labs, the guys who make the Sound Blaster cards, are those who are developing and sponsoring it. So it's probably going to live for a while. The problem with ALPy is that the wrapper is not complete. That you won't be able to do everything. You'll be able to do enough, though. And the basic concept is that you have a listener, which you position somewhere in 3D space. It's like a camera in 3D graphics. Has a position, has an orientation. So it's sitting somewhere and it's looking somewhere. And the other things that are going to happen are the sound sources, which are basically wave files or something similar that are played in a position as well. They have, in addition to a position, they have a speed. Speed is used for A, moving the sounds, and B, for things like Doppler effects. So you'll be changing, there's pitch changing as the sounds move. There's a nice little thing that's a loop flag, which is, it's astounding how often that is hard to do, looping sounds. Okay. It's a bit hard to get working under Linux. ALSA is something that is okay to get working, and the thing that is hard to do is getting surround setup working, and so that's, yeah, I think it's just something Linux hasn't had good sound support for very, very long, and it's just a matter of time for that to appear, but it's not all surround hardware will work under Linux. It might work with some outputs, it might work only with optical SPDIF, it might work only with electrical, it might only work with separate outputs through the stereo jacks, things like that. It's generally not very easy to get working. Okay, then the question becomes, why on earth do you need 3D sound? We usually, we won't need more than stereo in most cases. You won't have what games usually need, real 3D. You won't have a listener that moves through space. You won't have anybody, you won't have sound sources that move near them. But there's other reasons, very good reasons for using them. And that's, one is that you can separate sounds very good when you have more than 2 speakers. Just because the human ear is very good at discerning where sounds come from, and because that tends to figure out and separate things very well. One thing that it can be used for is background and foreground sounds. So you have, traditionally, you'll have foreground sounds through the center speaker, and you'll have background sounds everywhere else. That means you'll need less volume for more effect. You can also use multiple speakers for multiple listeners. So we haven't implemented this yet, but for the C-based scanner, it would be very smart to have foreground sounds, again, through the center speaker, that tell the person at the scanner what to do. And there's background sounds for everybody else who's near it, who, and they'll generally be listening to something else. They won't even need to know what the guy at the scanner is doing, but they'll have a general sound background. There's another thing that it'll do. Sound will create a virtual space. 3D sound works with delays between speakers. It works with reverb and things like that to give you the audio illusion that the room is bigger or smaller than it usually is, and or that it has a different texture, that you have a room made of metal when the walls are actually I don't know, wood. So a good sound designer will be able to use that. You definitely need more than 2 speakers for good effects along those lines. Okay, there's another alternative to Alpine. As I said before, Alpine is not complete, so PyOpenAL has a much larger subset of it. Problem I had with it was just random crashes. I don't know if I was the problem, or if it was PyOpenAL, or if it was drivers. That's just another alternative if you need more functions from 3D sound to look at. Okay, integrating this with libavg is obviously very easy. Just call the appropriate library functions in a libavg Python script, and it'll work. And the animation support that libavg has, which allows you to move things over time, will also work for the sounds. Okay, I've got an example. The problem is, what I'm going to do is try and move this near my laptop, and you're not going to hear much, actually. I'm going to show more of the code. Where is it? Okay. Okay, ja, das kriege ich jetzt nicht schnell genug kriege ich auch nicht schnell genug zum Laufen. Also das, ob das den Output gibt und so weiß ich nicht. Okay. I'm going to try this. I don't know. It doesn't make much difference actually. I can hear it. Nobody else can. Up. Please. Well, the thing is, you're hearing mono and I'm hearing stereo. Okay, the problem with this thing is that you're going to be hearing mono and I'm going to be hearing stereo, meaning I can hear it move and you can't. So I'll have to show you the code to make you believe it. Okay. There's a sound engine. There's a listener. Whoa, shit. Yeah. Okay. There's a listener that gets. Looks very very much like a camera in OpenGL. You have a forward vector and an up vector, which means this is forward. This is forward and this is up. It's just going to be 3D coordinates, and it starts a sound source, and then every 2 seconds it moves its position, and it really is that easy. Once you've got surround sound set up, it really does work in moving sounds. Okay, back to the rest of it. Okay, right here. Yeah. Okay. So, what if you need something else? It's actually very easy to wrap other C or C++ libraries for use with Python. There's 2 reasons for that. One is you've got code that's already there and that hasn't been wrapped for Python yet. And the second reason is you need something that has to be done in C or C++ because Python isn't fast enough. For instance, I don't know, complex image processing, things like that. There's a very, very nice library for generating wrappers. It's called boost.python. Basically, for every function you want to wrap, you have 1 line of code. And it does some incredible C++ template magic, which very few people understand. I think the person who wrote it himself said something like, I've got to rewrite it so I understand it. But it works, and it works incredibly well. It wraps every object-oriented thing I wanted to wrap, and that was a lot, in an appropriate Python wrapper. So that is the interface I would use. I tried Swig, which is another wrapper generator. It has it has one thing that makes it better, which is you can generate wrappers for lots of script languages, but it's a lot slower. The wrappers themselves are slower. We tested the speed, and it's somewhere between 3 and 10 times slower for a function call. And there's features missing. Things like return types of functions that should be giving you a derived class object, giving you a base class object, whatever. Things that sound complicated but are really necessary. But writing wrappers in boost.python was really, it was a no-brainer. I just wrote the lines I thought I would have to write, and it basically worked. Okay. A few other things that you can do for your other libraries that you can use when there's media systems to be done. Serial port support, that's a library called PySerial that, well, every device you want to put on a serial port can be done by that. libavg itself has support for setting individual parallel port pins. So if you have real crude, simple electronics that you just want TTL level signals to be put on, that'll do it. There's a Bluetooth library. There's lots of networking functions in the built-in Python library. There's database interface libraries. Python, there's a lot of stuff available for it. I'll go to the next point, which is how do you actually, when you're up to the point where you want to put it on a system that gets placed somewhere and will probably not move for the next few years and should also remain functioning. First of all, setting it up. And I think that's really by far the messiest part of everything, because Linux is not at the point where it's easy to set media systems up. There's two problem drivers, and that are just basically the main drivers that are going to be necessary. And one is video. You really need good OpenGL support. Usually that's not an incredible problem, but it can be hard to set up. Our second thing is sound, which is, as I said already, can be hard to get more than 2 speakers working. Okay. Then the question becomes, what in systems like this breaks? If you put up 1 or 2 PC, that's not going to be a problem. Or if it's just going to be there for a few weeks or something like that. If you put up 10, 15, 20 computers that are supposed to be there for 3, 5, or 10 years, things are going to break. Things in computers that break are usually, hard disks or fans. So what do you do about that? If they're broken, you fix them, and if there's a lot of them, it's going to be a lot of work. But you can always set up diskless systems. It's work to set them up because it's actually a pretty good tutorial on weird networking protocols. Because DHCP is what you get your boot plug from. Then there's something called pxe-grub that loads your kernel over the network. Then you'll mount a root file system via TFTP, and you'll use NFS as soon as the usual etc fstab stuff gets to work. But it does work, and it's actually, the systems are very fun to administrate once they do work, because you can change the configuration while they're not even running. So if you need to reboot the system, you start it rebooting, and then you change the configuration, and you usually change the configuration by the time it's powered down, so you can just power it up again, and it'll work. And if it can't boot anymore because you've changed configurations, well, you have a file system on a server to change and not a file system on a non-booting computer that you have to change. What is even more work is getting this to run read-only. Obviously, read-only adds another level of robustness. A computer that mounts its file system read-only is not going to destroy it. But that's even less standardized than diskless systems, so that's, yeah, there's more work to do, more Googling and stuff like that. Okay, fanless systems. It's basically a typical full-powered computer these days won't be running fanless. There's Intel Celeron and Pentium M systems, which are pretty expensive because they're usually industrial main boards, low volume things. They go up to, I think, 1.6 gigahertz, 1.7 gigahertz, something like that. Actually have pretty good performance. You can usually put a fanless but adequate graphics card on them. They work. And you can use via Epia systems, which are slow, fanless, and cheap. But incredible if they're if that's enough. They have nominal speeds of up to 800 megahertz without a fan at the moment. But you'll have a speed of about 400, 500 megahertz to your disposal if you compare it to a Pentium of that class. But on the other hand, these things cost, I think, 150 euros for the motherboard, including processor, and that's just absolutely unbeatable. Okay. I'm more or less done. The question is, what am I going to do in the future? libavg is not documented enough. There is a website at libavg.de, and there's some reference documentation which is more or less up to date, but there's no tutorial yet. So people who want to use it will have to look through the examples and stuff like that. I will be doing more of that. It was just a matter of time. Usually people promise to do documentation and they never do it. Well, I can just tell you I'm not that person, I think. I don't know. So there's a release that has to be done, stabilizing the API, things like that. I'd like to do a Macintosh port. I've had it running on the Macintosh already. Package management gets incredibly complicated on a Mac. And, well, the goal of everything, I haven't found an English word for that, and that's eigendynamic. It's what happened to my last open source library where that was PaintLib. I wrote, I think, about a third of the code in total. And if it happens to libavg that other people start pouring in code, that's the basic midterm goal. If it doesn't happen midterm, at some point libavg is probably going to die, but I'm pretty confident that I can make that happen. Okay, there is going to be a workshop on libavg usage and programming this Thursday, day after tomorrow, at 12 o'clock. The dates are there. The CBase is really, you can see the building the CBase is in that direction. So it's really 3 minutes walking distance. Costs a few euros because we'll be using CBase computers, and wear and tear and things like that have to be compensated. There's limited space. The room is not huge, so I'd ask you to send me an email if you want to come. Yo, any questions? Yeah, sure. Okay, there's a microphone coming. I can hear you, nobody else can.
Yeah.
Okay.
You said with 150 euros, these Epia boards are price-wise unbeatable. Have you heard about the Linux ports to consumer systems like the GameCube, Xbox, Microsoft Xbox, other like these devices, which, in my opinion, might also be quite a good platform for media systems like you are talking about?
Okay. Yeah, I think that is a good idea. No, I haven't thought about it. Actually, I think it depends on what you're wanting to do. If this is let's say if it's an artistic thing you're trying to do, if it's not long-term, if you're not going for years of stability, and if it's not a commercial setting, yes, it might be a very good project, might be lots of fun. If it's a commercial setting, you're never going to sell it to a customer.
Okay.
Okay. Okay, more questions? Yeah.
You mentioned that it's currently missing documentation. But what kind of users are you looking at? The programmers or the artistic kind of background people that could be kind of interested in learning Python and use of the library?
Both. Obviously, this talk was not for the artists. There was just too much technology in it. But I think, yes, it's possible to attract artists to things like that. There are other projects, processing, people using Director with Lingo, and artists using that, artists who can program to a certain extent. So that it does work getting artists interested. And the documentation is going to reflect that. It's going to be easier to read than this talk was to follow. Okay. Okay, thanks.